It's not on the moon. It's not in the depths of interstellar space either. The coldest place we know of, colder than anywhere astronomers have ever pointed a telescope, sits quietly on Earth, inside a research laboratory. Let's start with the baseline of everyone assumes is the true extreme. Absolute zero is the theoretical limit of coldness, to the point where all thermal motion should completely stop. We've never actually reached it. Even the empty vacuum of deep space isn't sitting at absolute zero. It carries a faint background temperature of about 2.7 Kelvin, roughly minus 455 degrees Fahrenheit, the leftover afterglow of the Big Bang itself, still gently warming the universe after 13.8 billion years. For decades, astronomers pointed to one specific place as the coldest natural location ever found. It's called the Boomerang Nebula, roughly 1,000 light-years away in the constellation Centaurus. Unlike ordinary space, this nebula is actually colder than the cosmic background radiation surrounding it, sitting at around 1 Kelvin, just barely above absolute zero. That happens because the nebula is a dying star violently expelling gas outward at extreme speed. As that gas rushes outward and expands rapidly, it cools itself down, the same basic principle behind how a refrigerant works, just on a scale involving an entire dying star. First identified in 1995 and confirmed again in 2013, the Boomerang Nebula genuinely earned its reputation as the coldest place nature has ever shown us. But here's the twist. Even the Boomerang Nebula isn't actually the coldest place we know of, not even close. In 2003, physicist Wolfgang Ketterle and his team at MIT cooled a small cloud of sodium gas down to roughly 450 picokelvin, half a billionth of a degree above absolute zero. That's not just colder than the Boomerang Nebula. It's colder by a staggering margin, roughly 2 billion times closer to absolute zero than the coldest natural object we've ever detected anywhere in the observable universe. The achievement still holds the official Guinness World Record for the lowest temperature ever measured. How do you even get somewhere that cold? Ketterle's team used a combination of laser cooling and magnetic trapping. Lasers, counterintuitively, can actually slow atoms down rather than heat them, gently absorbing their momentum from every direction until they barely move at all. Magnetic fields then hold those nearly frozen atoms suspended in place, preventing them from touching any surface that might warm them back up. At those extreme temperatures, something genuinely strange happens to matter itself. The atoms stop behaving like separate, individual particles bouncing around independently. They merge into a single, unified quantum state called a Bose-Einstein condensate, essentially becoming one enormous superatom, a state of matter that doesn't naturally exist anywhere else we know of in the universe. And the story isn't finished yet. NASA has taken the same idea into orbit. A device called the Cold Atom Lab, roughly the size of an ice chest, now operates aboard the International Space Station specifically to push these temperatures even lower. In the microgravity environment of orbit, atoms can be trapped more gently, using weaker fields than would be needed on Earth's surface, since there's no gravity constantly pulling them downward and adding unwanted motion. That gentler trapping should eventually allow researchers to reach temperatures even colder than anything achieved in a ground-based lab. Why does any of this actually matter, beyond simply chasing a record? At these extreme temperatures, quantum effects that are normally far too subtle to observe become large and measurable, giving physicists a genuine window into the fundamental behavior of matter itself. Some of this research even connects to understanding superconductivity and the gravity at their most basic level. There's something worth sitting with here. Humanity has now built something colder than any natural object we have ever detected anywhere in the entire observable universe, not out among the stars, but quietly inside a small laboratory room here on Earth, a genuine reminder of how much can still be discovered by patiently studying the smallest details of creation. What do you think? Does it surprise you that humans have built something colder than anything nature has produced anywhere in the universe we can actually observe? Let me know in the comments. Subscribe, because next time we are covering a genuinely wild theoretical idea that a dying star, instead of collapsing into a black hole, might create an entirely new universe on the other side.